Hey class, it's me again, and some more videos. Okay, this is chapter 11.1. We're going to skip over chapter 10 till the end of the year. And this section's about permutations and combinations. This is part 1. The schedule will be we're going to talk about this for the next 2 days, and then we got coming up spring break. Yay. All right. The objective today, we're going to take care of objective number 1 today. We're going to solve problems involving what we call the fundamental counting principle. And we'll take care of part 2 tomorrow. This whole section is about probability, like the probability that something might happen or not happen. Okay, here is the fundamental counting principle, and I'll read it to you, then I'll explain with a couple of examples. I think it's much easier that way. But the definition is if there are n number of items and n number of items and m1 ways to choose the first item, m2 ways to choose the second item, and so on and so on, there is m times m1 times m2 times no matter how many combinations you have to choose n items. That sounds really complicated, but it's really not. And the fundamental counting principle is really just a way to figure out how many different combinations total I can have of something. And we use multiplication to find out. Okay, let's do an example of the different combinations of clothes that you can wear. And let's just imagine for a second that this guy he's got 3 shirts that he can choose from, 2 shoes, and 1 different pair of pants. Obviously, this guy has probably many pairs of pants. Look how fashionable he's dressed with pink socks and matching tie. Let's just say that this is all he has, though. And I'm going to call shirt SH, and I'm going to call shoes SO, I can use shorthand. Now, if I wanted to figure out how many different combinations he could wear, if he only had this number of shirts, shoes, and pants, I could do what we call like a tree. I could make a tree, and I could say that he has 3 different shirts. So I could say he has shirt 1, he could wear shirt 2, or he could wear shirt number or 3. Then he has different options for shoes. He could wear shoes 1 with that, or shoes 2 with that, and so on and so on. So what I've done here is I've written the different options he has for shirts. He has 3 different options for shirts, and with each one of those shirts, he has an option of pair of shoes number 1 or 2 for each one of those. So each one of these is a different combination of outfits he has so far. But remember, we have to include the pair of pants as well. Actually, let's do something. Let's be a little bit more generous, and we'll give him 2 pairs of pants. I think it's a little bit, that's nicer, right? I'm sure he has more than 2 pairs of pants anyway, but let's go ahead and add those to our tree for the other combination. So with this outfit he has so far, he can wear pant 1 or pant 2 with that. For this one, he could wear pants 1 or pants 2, and so on and so on for each different outfit he has, and then pant 1 and pant 2. So if you look at this tree, I hope it's not too confusing, but what we have here is with shirt number 1, he could wear shoes 1 or pants 1. With shoe number 1, with shirt number 1, he could wear shoes 1 or pants 2. These are all at the end. These are all different combinations that he could wear. So let's count the number of combinations. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we just counted 12 different combinations. And again, I just want to reemphasize, each one of these paths on this tree is a combination of shirts, pants, and shoes that he can wear. So if you follow it all the way to the end, it gives you the different combinations. So counting the different combinations here, again, I got 12 different combinations. Now, it's take a lot of time to write all these trees for every kind of combination. So this is where we have the fundamental counting principle. What it says is instead of doing a tree like this, you could actually just multiply the different numbers of combinations that they have, and you'll get the same. You can multiply the different options they have together and get the total combinations. So let's check it out. So 3 shirts times 2 shoes times 2 pairs of pants equals, that's 6. 6 times 2 is 12. That's the fundamental counting principle. And just a simple example. This is actually a true story, but when I was working at a different school, a school called Marymount, my first job, the principal had bought the the kids in the school locks with only 2 rows of combinations. The lock didn't look like this, but it's the closest one I could find on the internet. And so, what's the problem with having a lock with only 2 rows of combinations? When I walked into this principal's office, I saw the big box of these locks like this. And I started laughing with the principal. The principal's like, "Why are you laughing? What's wrong with these locks?" And I was like, "Well, don't you understand that this is a very easy lock to break into?" And she was like, "Why?" Well, I explained to her about the fundamental counting principle. For the first row here, it goes from 1 to 9, or actually 1 to 0. So there's 10 possible combinations for each of the 2 rows. So we had 2 rows and 10 possible numbers for each row. So what are the total possible combinations? What do you guess? Well, 2 rows times 10 possible numbers gives you 20 combinations. Now, how long would that take you to figure out? You could sit there for 5 minutes maybe and guess that combination. For example, you could try 1 first. The first row you could try 1, 2, or 3, or 4, or 5, or 6, or 7, or 8, or 9, or 0, right? Then the second row, you could try 1, or 2, or 3, or 4, or 5, or 6, or 7, or 8, or 9, or 0. And you would get all possible combinations of this lock. So this is the fundamental counting principle. See if you can apply this to these 2 examples. Once you're done watching the video, we'll go over these 2 examples in class. Thank you.